So first question we're going to take a look at is solving a system of equations graphically. So this is the system we're going to solve. X cubed minus 5x squared plus 3x minus 2 and 2x minus 5. So our system already had y by itself, so we were able to type it directly in. If you have an equation where y isn't by itself, that would be the first step. Okay, we have to get y isolated. Otherwise, you can't type it in. Okay, so first let's graph it. Okay, so here's our graph. And first thing I'm just going to ask is how many solutions does this system have?
3.
3, yep. Each solution is going to be a coordinate. So we're going to need an x and a y value for each solution. Let's start with the one all the way in the lower left. Okay, how do I find the solution that's in the lower left? What do I have to press?
Second calc intersect.
Yep. Second calc, I'm going to do intersect. Now we pick a point on the blue, the red, and does the guess matter?
No.
As long as it's closest to us.
Right, we have to put it closest to the one that we want. So when we want the other ones, I'm going to have to move it. So there's our first intersection. So we get negative 0.65 and negative 6.3 for y. And I'll do another one. So second calc, option 5. This time move your cursor over towards the middle. And we get another answer. So x is 1, y is negative 3. And second calc intersect. Move our cursor, that's probably fine. 4.6 comma 4.3. That would be our third intersection point. I'm trying to get everything on the screen for you at the same time. Okay. Any questions on how we found all 3 of those? All right, so that's basically what you need to know from section 3.7. Okay, so the next question is a mixture problem where they're telling us we're starting out with 40 ounces of liquid, and out of that 40 ounces, 30% of it is acid. So to find a formula for the concentration, we have to find the amount of acid, and then we have to divide that by the original, or divide that by the total. So this mixture is starting with some acid already. It's not 40 ounces of acid because only 30% of that is acid. So how am I going to find out how much acid I'm starting with in my mixture?
You multiply 40 by 0.3.
Yeah, we're going to multiply 40 times 0.3. And that tells me I'm starting with 12 ounces of acid. And how much acid does it say I'm going to pour in to that mixture?
X.
Yeah, I have 12 ounces. I'm going to add X ounces to it. And now for my total, how much liquid did I start with?
40.
Started with 40 ounces. And how much liquid am I adding to the mixture?
X.
X. So there's a formula for your concentration as a function of how much acid you add to it. So there's your formula. Now let's graph it. So make sure we type that in parentheses. 12 plus x divided by 40 plus x. And as a decimal, what's the highest that this concentration could go? Can't go any higher. It's impossible to have a concentration that's higher than how much?
1.
1, yeah. Can't go any higher than 1 because that means 100%. And in this problem, the concentration really can't go any lower than what percentage?
0. Or
I can't.
0.3.
0.3, yeah, I can't go any lower than 0.3 because that's what the concentration is starting at. And if we don't pour in any acid, it will stay the same. If we pour in some, it'll get higher. What's the smallest amount of acid that we could pour into the mixture? Like, could we pour in -10 ounces?
No.
No, that's too small.
1.
We could go less than 1.
0.001.
We could go less than that. What's the smallest amount we could pour in? It says you're going to add X ounces of pure acid. Well, I could decide to add how many ounces?
0.
Yeah, I could add 0. Right? There's nothing wrong with just leaving it the same and adding nothing to it. We could definitely add nothing. And then the X max is the upper limit on how much acid we're going to pour in. So if we hit graph, we should get a nice curve that shows us our concentration. And we're trying to figure out when the concentration reaches what level? 80%. So what would I put in on Y2?
80. Or 0.8.
0.8, yeah, because concentration is always between 0 and 1, the way we're doing it. Okay, so yeah, we got plenty of space, we can see it. And what do I have to calculate?
The intersect.
Yep, calculate the intersect. And we would have to add exactly 100 ounces of pure acid to the mixture we already have. And that would make the concentration go up to 80%. And that's a mixture problem. Okay, so next question we're going to look at involves determining the transformations of a rational function. So you could see the question like that. You could also see it written like this. That's exactly the same question. First thing is to determine how many transformations there are, which in this case there are 3. So we have, or on, I forget what day it was, but I think it was earlier this week. I gave you guys a diagram and I labeled everything with A, B, C, and D and told you the order and what each number did. Okay. Which number do we start with here? The 3, the -4, or the -5?
3.
Nope, that's going to be the second one we do. So we're going to do that one, but we're going to hold off on that one for a minute.
So then would it be the -4?
The -4, yep. And what is subtracting inside the denominator going to do to that function? Yeah.
It's going to go right 4 units.
So that's going to do a shift right 4. Perfect. Okay. Now we're going to look at the 3. I like to think of it as a times 3 in front. But if the 3 is in the top, it's the same thing. What does times 3, and now we're on the outside of the fraction. What's the times 3 going to do? Yeah?
Is it a vertical stretch by factor 3?
Yep, anything on the outside of those black parentheses, that's going to be a vertical. And because it's multiplication, it's a stretch. So vertical stretch by factor of 3. Okay? And now the last thing to look at is the -5. It's on the outside, but it's subtraction. So what does the -5 do?
Vertical shift down.
Yep, how many?
5.
Perfect. So shift down 5. So when I ask you to describe transformations, that's exactly what I'm looking for you to do. All right, so next question we're going to look at is finding the domain of a rational function. And when we find the domain, all we have to do is focus on the denominator and make sure that the denominator is never what number?
0.
Yeah, we never want it to be 0. So how could we make the denominator, how could we rewrite the denominator so it's easier to see what makes it 0?
By having it equal 0? Or?
So we are going to set it equal to 0, but I want to rewrite it in a way that's going to make it easier to solve once I set it equal to 0. Yep.
Can we factor it as x plus 2x minus 3?
So we can factor it as x plus 2, x minus 3. And now when we're looking at that, let's double check it. Looks good to me. What are the two numbers that would make the denominator 0? Yeah.
-2 and 3.
-2 and 3. So are those the numbers that you can use in the domain or you can't use? Yeah.
Wouldn't it have to be -2 because the negative times positive equals a negative, and you have +6?
Yeah, you're right. Did I make that so it's not factorable? Maybe. So what I'm going to do is just adjust the original problem because I want something that's factorable. So now x squared minus 3x plus 2x. Okay, now it works. So you're going to have one that is factorable. So okay, so we got -2, +3. Now that works. So are these the numbers that you can use in the domain or you can't use? Can't use. So think of them on a number line. Basically, it's like a number line with 2 holes in it. You can use anything you want on that number line except where the 2 holes are. So how would you write the numbers that you can use in section 1? What would that look like?
Less than
We're going to do it as an integral.
Oh.
Yeah, but it would be anything less than -2 as an inequality. How about as an integral? Yep.
Open parentheses, negative infinity to -2.
To -2, perfect. Including or not including -2?
Not including.
Not including. Or, what's the next? We'll call this one section 2. What would be the numbers I can use in section 2?
-2 to 3, both open.
Yep. So open interval there. And the last section of numbers I could pick from?
3 to infinity is also both open.
Yep. So that is how you would write the domain using interval notation. Any question on that one? Okay, so in this one we're going to find a polynomial with certain roots. In this case, both of the roots are complex. If they only give you one root, remember, roots always occur in pairs, complex roots, specifically conjugate pairs. So if we know that 3 minus I is a root, then what would be the factor that came from? Yep.
X minus 3 minus I.
X minus, we got to write it like that. X minus our root, because if you filled this in right there, you would have 3 minus I minus 3 minus I. That's 0. How about this one? If 3 plus I is a root, what factor would that have come from?
X plus.
It's always x minus your root.
So x minus 3 plus I?
X minus 3 plus I. Okay. Now, what would be our first step to simplify both of those? What could we do on the inside of each one? Something we could simplify, because we have parentheses.
My dad's here, so I have to go.
Okay, so what can we do inside here to start to simplify that? It's like a step before we're going to do all our distributive, our formula. So what about that negative in front of the parentheses? What can we do with that? Yeah.
Could we distribute it across the
Yeah.
parentheses?
So we want to distribute that out so we no longer have to deal with the parentheses inside the parentheses.
Doesn't it just equal -1 pretty much?
Yeah, it's like distributing -1. Yep. And then what about when you do that over here?
You get x minus 3 minus I.
Okay, now we're going to multiply all this together. There's 3 terms times 3 terms. That means you're going to have 9 terms when you multiply it all together. So, and a lot of those are going to cancel out because these are conjugates. Okay, let's start with x times x gives me
X squared.
x times negative 3,
Negative
and x times negative I.
negative
Negative ix. Okay, now let's do the negative 3. What's negative 3 times x?
negative 3.
And negative 3 times negative 3?
Positive 9.
Positive 9. And negative 3 times negative I?
3i.
3i. Okay, and one more time. What's I times x?
ix.
Positive ix. What's I times negative 3?
Negative 3i.
Negative 3i. And I times negative I.
Negative I squared.
So it's negative I squared, but I squared is what number?
Negative 1.
So that's really negative 1.
So positive 1.
That's a positive 1. Okay. Anything there that is going to cancel out?
Positive 3i and negative 3i.
Positive 3i, negative 3i. So that's gone. Okay.
Positive ix, negative ix.
Yes. If all the i's don't cancel out, we've done something wrong. Okay. There's i's left. There shouldn't be. Now just combine whatever we have remaining. So we got x squared. And what else?
Minus 6x.
Minus 6x. Yep.
Plus 10.
Plus 10. Perfect. So that is a quadratic polynomial that has roots of 3 minus I and 3 plus I. And if you really wanted to verify it, use quadratic formula on it and solve it. And those are the two answers you'll get, 3 plus I and 3 minus I. All right, so in this one, we're going to find the roots. Okay, are we starting with a quadratic? No, then we cannot use quadratic formula. We need to start by finding a root that we can basically pull out of that polynomial. What theorem can I use to generate a list of possible roots? Yeah.
The rational roots thing.
Yep. So we use the rational root theorem. What are the factors of p, my constant?
1, 3, 5, 15.
So plus or minus 1, 3, 5, 15. And what are the factors of q?
Wouldn't it just be 1?
Just plus or minus 1. Any questions on that? Okay, so now because q is just plus or minus 1, when we do p over q, q doesn't make a difference. So essentially my rational roots here are just the p values. So what I want to do is graph that. And what would I need to set my x min and my x max to guarantee I could see all those possibilities?
Would it be plus or minus 15?
Yeah, I would go at least, maybe we'll just do 20. But yeah, you got to go at least to negative 15 and 15. So negative 15 to 15 on the x. Y doesn't really matter because you're just looking where it crosses the axis. As long as you can see the axis, you'll be all set. Okay, let's hit graph. And out of all the numbers for p, do any of them look reasonable for where they could cross the x-axis? 3. Yep. So 3 looks like it could be a rational root. I can check it by tracing to it. It is. So 3 is a root. But what I care more about now is using that to figure out the other roots. So what am I going to do with the 3 now?
Would you plug it in for x?
Well, if we plug it in for x, we know we're just going to end up with 0 because
Oh, yeah.
that would just tell us that it's a root.
So we synthetic divide by.
Right. We have to do synthetic division, and we're not really interested in the remainder. We need the
The quotient.
quotient. Yep. We need the quotient. So Cole, what would I put on the inside for my numbers?
1,
Yep,
-4.
0 first.
Oh, yes.
Yep, then -4.
And -15.
Yep. So just don't forget the 0 because of that x squared term. There isn't one. Okay, bring down my 1. 3 times 1 is going to give me 3. What's 0 plus 3?
3.
And 3 times 3?
9.
9 plus -4.
5.
3 times 5?
15.
15. And add those up?
0.
0. So now we're left with that. Okay. When I write that out, what kind of polynomial is this now?
Quadratic.
It's a quadratic. It's x squared plus 3x plus 5. So now we're going to try to solve that. Doesn't look factorable. So what else can I do besides factoring? Yeah.
Would it be the quadratic formula?
Yep. So we're going to have to do quadratic formula to get the other 2 roots. All right. And when I look at this graph, I don't see any other x-intercepts between -15 and 15. What do you think that means about the other 2 roots, since we don't see them on the graph?
That they're larger.
Well, yeah, you're right. They could be larger if they were irrational. But let's work off the premise that they're not larger than 15 or -15 if they were real numbers. So what else could they be?
Imaginary?
Yeah, they're going to be imaginary. And if we zoom out, we could probably start to see that. I don't know how much we'd have to zoom out. But yeah, there it is right there. I don't know if you see it or not. There's the turn the cubic's taking. It's way too low to have the x-axis hit that. It only hits 1 time. That proves to me the other 2 answers are imaginary.
How much did you zoom out for that?
I just did zoom out, and the
Oh.
calculator picked whatever it wanted to do. Yeah, I just did zoom out. So now let's plug into the quadratic formula. -b plus or minus square root of b squared minus 4ac all divided by 2a. Okay, let me make sure I did all that right. -b plus or minus the square root of b squared minus 4 times a times c. Okay, what's 4 times 1 times 5? That gives me 20. And what's 9 minus 20?
11.
-11. And how do we simplify the square root of -11 so we don't have a negative under the root?
Would be I, the square root sign, and then 11.
Yep. So these are the other 2 roots to the problem. So 2 imaginary and 1 real. And that's how you find roots that are complex in polynomials. Okay, so this question is asking us to find the asymptotes. There are 2 kinds of asymptotes that we've worked with, horizontal and vertical. Let's start by factoring that whole thing, and then that's going to help us, especially with the vertical asymptotes. How does the top factor?
X plus 2, x plus 1.
If it was x plus 2, x plus 1, that would give me a 3 in the middle and a 2 at the end.
Oh. Is it? X plus 1, x plus 1.
Yep, so the top is x plus 1, x plus 1. And what does the bottom factor as?
The x plus 6, x plus 1?
That would give you 7 in the middle, if you did it that way. You'd have 7x when you FOIL that out.
Oh.
We need 2 numbers that multiply to give me 6 and add to 5.
Oh.
X plus 2, x plus 3.
Yep, x plus 2, x plus 3. All right, so now let's do the vertical asymptotes. how do you find vertical asymptotes? You have to figure out what happens.
Is it where the bottom equals 0?
Yep, it's where the bottom equals 0, as long as there are no what? Common factors. And there are no common factors between the top and the bottom here. So wherever the bottom is 0, those will be asymptotes. What could you plug in to make the bottom 0?
-2 and -3.
And how do you write those as equations?
Is it a coordinate?
No, it's an equation. So I'm looking for something with an equal sign.
Y equals, no, X,
X,
sorry.
yeah, X is vertical. X equals, X equals. So those are your verticals. And now to find the horizontal, what do we find first that helps us do that?
The
The EBM. Yep. So let's find the EBM. Even though they didn't ask for it, that's what's going to help us. Okay. What's the highest degree term in the top?
X plus 1.
So to get the highest degree term, you have to have it fully multiplied out.
Oh, so would it be x squared?
X squared. And the highest degree term in the bottom?
X squared.
X squared. So what is my EBM?
1.
1. So now when I write my asymptote, what happens to the number in that box as x continues to get bigger and bigger?
Stays the same.
It stays the same. So you're going to have a horizontal asymptote at 1. Good. Any question on finding your asymptotes? Okay. Okay, so we're going to continue looking at this problem to do the next topic, which is describing the behavior as you approach an asymptote. Now, how many sides can you approach an asymptote from?
2.
2, right? There's the positive side, which means coming from the right, or the negative side, which means coming from the left. So I want to describe the behavior. Let's do both. So let's type in our problem. X squared plus 2x plus 1. And we're going to divide by x squared plus 5x plus 6. Okay, let's go to our table. Now, we can check if we want to make sure we found the right numbers for asymptotes. -3 gives me an error, and -2 also gives me an error. So what I want to do is, let's describe what happens to f of x as x approaches, let's say, -2 from the positive side. So what would be a number that I could plug in that's approaching -2? So here's your number line, here's -2. Coming from the positive side, what's a number that's very close to -2?
-1.99.
Yes, -1.99. So I'm going to type that in. Oh, I went a little more than I needed to. It says -2, it's not really, it just rounded it. But when I plug in -1.99, I'm at almost 10,000. So what's happening to f of x as you approach -2 from the positive side?
It's increasing.
And what is it increasing to?
10,000.
No, not
Oh,
10,000.
positive infinity.
Positive infinity, yeah. The 10,000 is just kind of like a sample point that we tried. But yep, it's increasing to positive infinity. So you would say f of x approaches infinity. Now, if I said, describe what happens to f of x as x approaches -2 from the negative side, what would be a number that is on the negative side of -2?
-2.1.
How about even closer?
2.01.
-2.001. Okay, very, very close. We're at -1,000. All right. So that means you're approaching what on that side?
Negative.
Negative infinity. Yep. So if I ask you to describe the behavior near a vertical asymptote, that's what I'm looking